right, friends, taking a look at our review here. Now, taking a look at question number 1, it's asking us for our 5-number summary. So 5-number summary is going to be our minimum, Q1, median, Q3, and maximum. Kind of not including outliers or talking about outliers, that's going to be our box plot, more or less. So let's use our calculator to find that. We're also going to find the sample mean, the variance, the standard deviation, and the IQR for this data set. So taking a look here, I've already punched in all of these numbers into our calculator, so that's the first step. If you want to pause the video and do that, you're welcome to, but to save time, I just already had it punched in. So let's find our 5-number summary here. So to find our 5-number summary, I should probably keep my calculator over here. After we have all of the data punched in, we're going to go to seconds, or sorry, not second stat, just stat. Getting ahead of myself. We're going to go to stat, and we're going to go right to calc, and number 1 var stats. Right now, our data is already punched in, and we don't have a frequency table here. It's just raw data, so there's no need to do L1, L2 or anything else in here. So it's automatically going to select L1 if you don't have anything here. If I had put this into L2 or L3, then I could go second 2 if my data was in L2, and then that would pop up, but it's not in there. So if you leave it blank, it's automatically going to select list 1, which is usually where you're going to be putting raw data. So we'll hit enter. And let's just start filling this out as it shows up on our calculator. So we are going to be using X bar here as our mean. So that top number there is our mean. So 10 point, let's just say 9.3. So both of these are technically standard deviations. However, we're going to assume that just about everything, every data we collect in here is a sample. Let's just say that this is a sample of all Lake Braddock students, even though it's a bias sample. We'll talk about that in Unit 3. But we're going to be using this S sub x here as our standard deviation. Okay. We'll scroll down to get our 5-number summary. So our minimum is going to be 1. As we can see here, I scrolled down, and here's the 5-number summary. Our Q1 is 4. Our median is 10. Our Q3 is 17. And our maximum is 20. Okay. Now, to find our variance and our IQR, we need to do a little extra math. Yay, lucky us, right? So I'm going to clear out of this. So calculator can't automatically calculate variance for you, but variance is just the standard deviation squared. Well, I have my standard deviation here, so I'm just going to square it. And that gives me my variance of 37.33-ish. Right? And then for our IQR, well, the formula for IQR is just Q3 minus Q1. So my Q3 is here, 17. I'll do this one in my head. 17 minus 4 gives me an IQR of 13. Now they're also asking if there are any outliers in this data, and show your work and justify your decision. And here is our formula. Again, this formula will not be given to you on the test. So our formula is here. No formula, not on the formula sheet, so you need to know this one on your own. So let's plug in our numbers from up here. So if any x value is less than 4 minus 1.5 times my IQR of 13. I have a feeling that there's not going to be any data values less than this. So if anybody guessed less than negative 15.5 Disney villains correctly, then they would be an outlier. Obviously, that's not possible. So then any data value that's Q3 plus 1.5 times the IQR, or greater than Q3 plus 1.5 times the IQR, would be considered a outlier. My Q3 here is 17. I have a feeling that we are not going to have any outliers on this data. And that's going to be 36.5. Oops. Didn't show my work. Come on, Mr. Whitesell, you've been doing this long enough to know better than that. So any x value that's greater than this, hopefully I think I did it right on the key. So any x value. Now again, my data is going to be slightly different than yours, but the keystrokes are all going to be the same here. Right? So are there any outliers? No. Why not? There are no data points. Less than negative 15.5 or greater than 36.5. Right. All right, let's make our histogram now of this data. Now, a couple things I wanted to highlight with this histogram. First is that I have made sure, I've already set mine up, I've made sure that I have labeled both of my axes. Please do not forget to label your axes. Right, now let's take a look at what happens when I create this. So, whenever I'm making a continuous histogram or have multiple numbers within a range, we want to make sure that we understand that 4 here does not go in our bar down here, but goes in the bar above. So these numbers on the edge go into the next bar up. So how many numbers do I have between 0 and 4, not including 4? Well, there are 4 of those. The next thing we want to make sure that we're doing when we create our histogram is make sure that our bars are connected to each other. If I separate those, that makes me think that it's a bar graph. That makes me think that basically these aren't numbers, that this is categorical data. In this case, it's not categorical data. All right, so how many between 4 and 8, including 4 but not including 8? Well, there are 3 values there. For me. Again, yours is going to be slightly different. Make sure you're making your own. My data set had 7 individuals between 8 and 12, including 8, not including 12. Go up to my 7. And go down to 12. Or up to my 12. My data set had 5 individuals between 12 and 16, not including 16. My data set had 6 individuals between 16 and 20, not including 20. And then there's only 2 individuals who scored a 20, basically. So notice I had to make this go, even though my data only goes up to 20, I had to make this go up to 24 because 20 needs to be included somewhere. 20 wasn't included in this, so I needed one more step up. So that's one thing I wanted to make sure that I highlighted. So what is the highest possible value for this? Well, considering we have discrete data, the highest possible value would not be 24, it would be 23. Again, 24 would be in the next bar above, 24 is not included here. Okay. So taking a look at the next page, how could I create a box plot for this? And I'm not going to actually create it, but I'm going to show you how to do that on your calculator. So if I wanted to create a box plot for this, you can check the key for my actual box plot. You can go to second y equals, make sure your plot 1 is on, and choose this modified box plot right here, because if there are outliers, I want to show that there are outliers. So clicking here, XList is L1, that's where my data is. In this case, there's no frequency table, so your frequency must be 1 here. Check this before the test. Don't often give frequency tables, so you want that default 1 to be there. Right? And then since everything's good, I'm highlighted up here, there's no A, there's no second, so I can just go zoom 9, and here's my box plot. Well, how can I use my calculator to figure out what each of these values are? Well, if I press the trace key right here, it gives me my 5-number summary again. I know I already wrote it, but if I hadn't, it gives me my 5-number summary. Well, here's my minimum of 1, here's my Q1 of 4, here's my median of 10, here's my Q3 of 17, and there's my maximum of 20. So my 5-number summary all right there. If I had any outliers, I could keep scrolling right to find outliers. And if there were outliers, it would give me the maximum without outliers. All right, so let's describe this distribution / our histogram. So again, anytime you hear describe or compare the distributions or discuss the similarities between the distributions, you're going to want to hit your socks. Okay? So first thing we're looking at is our shape. Well, if I was looking at this box plot, all my whiskers are pretty even. Each part of my box is more or less the same. Median's kind of in the center. This is a roughly symmetric box plot. If we take a look here, again, it's a little bit less clear that we have symmetry, but this is going to be more or less symmetric. We don't really have to talk about modality here. If you said bimodal, I'd probably accept that. But for this one, since there's no distinct like 1 peak or 2 peaks or things like that, it's not exactly uniform, but it's close-ish, I would just talk about the symmetry of this. And again, for this box plot, for a box plot, that's about as symmetric as you're going to get. So I would say the distribution of correctly identified Disney villains, or correctly identified movies, is roughly symmetric. Notice that I'm already including context here. You want to make sure that you are hitting context, and I would do it right from the start. I would do it in every sentence that I have, just to be extra safe, just in case Mr. Whitesell is feeling a little perturbed or something like that, and let's not give him any chance to take any points away from us. So we've talked about our shape. Are there any outliers in this data or any other unusual occurrences? Well, let's take a look at our histogram. So let's take a look at our modified box plot first. No outliers. Plus, we already solved that out. Thanks, Mr. Whitesell, for making us do that. No real gaps in the data. No real clusters anywhere. You could talk about the clusters between 8 and 12 and 16 and 20, but it's not really necessary for this one. So the distribution does not have any outliers or other unusual occurrences. All right. Now, let's take a look at our center. Well, I've already calculated my median. I've also calculated my mean. Either one's going to be fine since I have roughly symmetric data, but let's just use the median. Median net, you can never go wrong with the median. So the median of correctly identified movies is 10 movies. Again, what's my unit here? Well, it's correctly identified movies, so it's 10 movies. I would include this unit here, even though I kind of included it over here. But yeah, I would include that. Now, for our spread, let's just use our range because it's just super quick, although IQR we did already calculate, but 20 minus 1 gives us 19. The range of correctly and I know how to spell, identified movies. Oh, struggling today. Is 19 movies. Right? So I've hit my outliers, I've talked about that. I mentioned the median, I've talked about that. And I have my spread here as well. Okay. Now, which measure of center and spread would be most appropriate for this data set? Either would work. Because I have roughly symmetric data, I can use either. I know in my key I said mean and standard deviation because it's roughly symmetric. I'm going to kind of change my answer here. I would count either as long as you justify your answer, but median is never an incorrect answer. So I would say median IQR because the data is roughly symmetric. Any measure is appropriate. Right. Now, the student with the lowest score in the class miscounted and really did even worse. I know we have a 0 in there. Let's pretend that they got negative for some reason. Here's the concept. They got none correct. It says none. We're gonna say that they got a negative value. How does this affect the median? How about the standard deviation? Well, let's think about this concept, and I'm going to give another example here. So let's say we have 5, 6, 7, 8, 9. Let's take a look at this data set right here. And you can always do this if you're having trouble with a problem. Just choose a small data set where it's easy to find the median and easy to find the standard deviation. So we have 5, 6, 7, 8, 9. Well, my median here would be 7. And my standard deviation wouldn't be whatever, something not that big, right? But now let's change this data set and let's say that, okay, this is 0, 6, 7, 8, 9. Well, what's my median? Well, that stays at 7, so that's fine. But now I have one data. Here the mean would be 7. In this case, the mean would drop a little bit. But this data point is now further away from my mean than it was up here. So my standard deviation is going to increase. So the median stays the same. The standard deviation increases, right? Because now that average is going to go up because I have a slightly larger deviation here, right? I'm not going to go through the marginal and conditional distributions. I'm going to let you check the key for that, but stay tuned for the next video to look at those, to talk about our last page on the review. Right? Hope you found this helpful.